Okay, today's problem is solve the equation sine x plus pi over 6 minus sine argument x minus pi over 6 equals 1/2. Find x. Find x. Okay, well, in this situation we have phase changes, right? Phase change is pi over 6, so we're shifting the sine function to the left here and to the right here, okay? But with all this going on together, we want to find the combination of these two actions, where you're subtracting one from the other, okay, and that equals 1/2. So where does all this equal 1/2? This x value, where would we be? What angle would that be? And so the best approach to this would be to go back and use our identities, addition and subtraction identities, because the sine of a plus b would be equivalent to this expression, and then the sine of a minus b would be equivalent to this expression. So we got both of those at play here. So let's trade it in and see where that gets us. So we're going to transform this expression into another expression. Okay, so let's see. First, I'm going to write out the long form. So I have sine of a plus b minus the sine of c minus d equals 1/2. And that's the format that you see with the identity, except it's not a minus b, it's a c minus b in this case. All right. So let's write it out longhand. So that basically is the form we see, and then I'm going to expand this form here. So I get sine a cosine b. Okay. In this case, it would be plus cosine a sine b, and then minus. This here is going to be expanded now. Okay, minus, and I have to go down and pick up the other identity using the minus sign, not the plus. And it just is the same thing but minus. So let's continue on. Sine A, sine C, cosine, okay, D minus cosine C sine D equals 1/2. Now I can see you can make an error here if you didn't put that minus sign in front of it over here. This comes from the identity though, so just make sure you bracket this and you're following that minus sign. Okay, now let's insert what is A, what is B, what is C, and what is D. Okay, well, B and D are the same, and so are A and C. So we could have just made this A and B, but sometimes these are not the same. So I chose to use alternate designations for a future problem. Okay, let's see what we got here. Sine A is sine x, and I have cosine of pi over 6 plus cosine x sine pi over 6 minus sine x cosine pi over 6 minus cosine x sine pi over 6 equals 1/2. Okay, now we got to go to our unit circle and see what this pi over 6 is going to deliver. Well, here we have the pi over 6, 30-degree angle, and we got the x value and the y value. And as you know, the sine of x equals, on the unit circle, is equal to really y over r. Sine of an angle, rather, let me give it theta so you don't get confused, is y over r, but r equals 1 on the unit circle. So if you multiply this over, you get y equals the sine of theta. And likewise, or similarly, the cosine of an angle is x over r, but r equals 1. You multiply, you get x equals the cosine of the angle. So in this case, if we're dealing with unit circles, we have the y value is just the sine of this, and the x value is the cosine. So we're looking at pi over 6, that just would be returned. So the cosine of this would return the x value, the sine of this would return the y value. Okay, so getting back to the problem, we have the sine x, and now the cosine of pi over 6, square root of 3 over 2, okay, plus the cosine x, and now the sine of pi over 6, 1/2, minus the sine x, and then the cosine of pi over 6, square root of 3 over 2. Then minus cosine x, and then the sine of pi over 6 is 1/2. And that end bracket is 1/2. Okay, let's put this together and try to clean it up a little bit. So I find that I have square root of 3 over 2 sine x plus 1/2 cosine x minus square root of 3 over 2 sine x plus cosine 1/2, excuse me, cosine x equals 1/2. Well, if you notice quickly, this guy here is going to drop out, and you got 1/2 plus 1/2 cosine x, so that's cosine x equals 1/2. So now you're saying, well, when or what angle would I use that would deliver me a 1/2, which is the x value? Well, look at our unit circle. Well, where's the x value? 1/2. Not at 0, not at 30, not at 45, but it is at 60. So it's at 60. So we say, and you would be doing this by using arc cosines or inverse cosines. So you would say, well, what x angle equals what? The cosine inverse of 1/2, you see? So this is the inverse trig function here we're employing. All right, we're employing an inverse trig function, and that has a few other, there's one other thing here to recognize, and that is that's not the only place that we get 1/2 angle. We also have 1/2 angle down here, 1/2 value for x at 300 degrees, or 5 pi over 3. So it's not only at this doesn't only give us pi over 3, this also, which would be 60 degrees, we also returning the angle of 5 pi over 3, which would be 300 degrees. Now the question is, which one of these is the proper angle? Well, there's a technique we use. Since we're employing inverse trig functions, we must recall that these are domain restricted. Okay, domain restricted means it wouldn't be a function unless we restrict the domain of a cosine when we're dealing with the inverse cosine. And basically, we use the sun diagram. I'll expand on this for a little bit in a second. Let me just look at this. So we use this thing called the sun diagram. And when we're dealing with inverse trig functions, these functions must return an angle. And these quadrants, cotangent. Okay, so this is quadrant 1. This is quadrant 2. So we have to have cosine, secant, and cotangent must return angles in these quadrants. Now let's look at the other 3 functions. You'd have here the sine and the cosecant and the tangent must return angles in quadrant 1 and quadrant 4. Okay? Based on these domain restrictions. Okay, so 300 degrees is clearly in quadrant 4 for the cosine inverse, so that wouldn't be allowed. So this would be quadrant 4, and that's not allowed. That would be over here. We need something in quadrant 1 or 2, and so that is the answer. It'd be pi over 3 or 60 degrees. Now, what about this domain restriction? Well, if you look at this, the inverse function of the cosine, okay, if you do an inverse, to see if it's a function, you would use a horizontal line test, okay, to test for what? To test if it's a function. Okay, so in other words, we're talking the inverse, so you're switching the x and the y here, okay? So that's what the inverse function is doing. You're replacing the x with the y and the y with the x, and then you would do a horizontal line test, okay, instead of a vertical line test for inverse functions. And that's a whole nother lesson. But basically, the way we get around that is we restrict the domain for the cosine to live between one part and another, and that is between 0 and pi. So we go from here, okay, to here. If we restrict the domain just in here, we can do the vertical line test all day long, and it is a function. So therefore, that's the way this sun diagram is telling us. Stay within 0 and pi, and you're okay. Over here, you stay within minus pi over 2 and plus pi over 2 for these functions, and use the sun diagram, and you'll get the right angle. Well, that's the lesson for now. Thank you.